All right, today we're going to look at lesson 1.2 and we're going to be solving multi-step equations. Now let's review last week's lesson where we learned about simple equations. Somebody raise your hand and tell me what a simple equation is. In your own words, what is a simple equation? Gage.
An equation that only has one step.
Okay, it has one step, right? It had one variable. It had one number keeping the variable from being alone. It had one step. All right, today we're going to get into multi-step equations. And the essential question for today is, once again, how can I use a multi-step equation to solve real life problems? All right, that's what we all want to know. Where am I ever going to use algebra in real life? All right, so by the end of this lesson, we should be able to see where we can use multi-step equations in real life problems. Now, multi-step means more than one step. And so sometimes we look at a problem and we just don't know where to start. So I use the acronym, Don't Call Me After Midnight. And this is going to help us organize our thoughts, all right? Are we going to have to do every step for every multi-step equation? No. But we need a place to start and a place to work to. So we start with the D in don't, which stands for the distributive property. Before we can work any type of equation, we have to do the distributive property if it's in the problem. Now, let's review the distributive property. We know from the order of operations, please excuse my dear Aunt Sally, that we are supposed to start our work in the parentheses, correct? But what happens if the parentheses look like this? Can we actually add x plus 3? No, because one's a variable and one's a number. So a lot of times when we see this type of parentheses, we also see a number that's sitting right outside those parentheses with nothing between the number and the parenthesis. What operation does that stand for? Multiplication. So when we have a set of parentheses and we can't actually do the work inside, and there's a number sitting outside waiting to be multiplied, that is where we would do the distributive property. We would take 2 times x and go back out and then do 2 times 3. All right, so we're looking for the distributive property first. That would then take us to the second step, which is to combine our like terms. Now, let's talk about like terms. If I give you 2x plus 5, are those like terms? No. What makes like terms like terms? You remember? Same variable raised to the same power. So obviously the first term has an x, the second one does not. All right, what about if I gave you 2x plus 4x? Are those like terms? Yeah, they got the same variable raised to the same power. Okay, what if I give you negative 2 plus 3? Are those like terms? Why not? The definition says same variable raised to the same power. Do either of those have a variable? Then aren't they alike? And can't they be combined? Yes, okay? So we're looking for like terms. But here is the trick to this, all right? And I would add this into your notes, all right? Right next to combine like terms, I want you to add this note. We're looking for like terms that are on the same side of the equal sign. So when we get to the combine like terms step, we're looking for like terms on the same side of the equal sign. So again, for example, if we have 2x plus 3x equals 5, do we have like terms on the same side of the equal sign that we can combine? Yes or no? Class, yes or no? Yeah, 2x plus 3x, that's on the same side of the equal sign, so we can combine them. All right, but what if I had 2x equals 3x plus 5? Do I have like terms on the same side of the equal sign? No. So in this problem, I would skip that step because I'm combining like terms that are on the same side of the equal sign. All right, then that brings us to step number 3. The me stands for move the variable. Now, this is one of those steps that do you absolutely have to move the variable to the left side? No. However, we know that our final answer, where do we want the variable? We want it first, right? Which is the left side. So we're going to try, if at all possible, we're going to move the variable to the left side. Now, let's talk about that for just a second. Again, if I have 2x equals 3x plus 5, can I move the variable to the left side of the problem? Why not? Yes, no, maybe. Okay? I can. If I move 3x to the other side, to the left side, what's left on the right side of the problem? A 5. So in this particular problem, yes, absolutely, I can move my variable to the left side. Is it wrong to move 2x to the other side? Is it wrong to go this way? No. But if we're trying to make our lives simpler and we're trying to get to an answer that we all want, then moving it to the left side makes things easier in the end. All right? Now, what happens though if I go back and I have 2x plus 5 equals 3x? Now would it make sense to move the variable to the left side? No, because what happens if I move 3x, what's left on the right side of the problem? Nothing. So if by moving the variable to the left side of the problem, we're left with nothing, don't do it. All right? So for this particular problem, we would have to move the 2x over. All right? So moving the variable. This is only going to happen, there's going to have to be a variable on both sides of the equal sign, and then we're trying to move that variable term to the left side. All right? Now that brings us to the after. The A stands for add or subtract. See, we get to multi-step equations like this, 2x plus 3 equals 6. And we got how many numbers that are keeping x from being alone? Look at x. How many? There's a 2 and a 3, right? So how do I know which one to move? I can't divide 2 and then subtract 3. My answer will be wrong. So the order is add or subtract, then multiply or divide. Okay? Add or subtract, so we would subtract 3 from both sides. Then we multiply or divide, so we divide both sides by 2. All right, again, this is the acronym. Are we going to have to do every step every time? No. But this helps us organize our thoughts, and the better we get at it, the quicker we're going to go through it. All right, so let's put this into practice. If you look at A, B, C, and D, let's look at this whole screen collectively. Do you see a problem where we are going to have to do the distributive property first? All right, which one?
D.
Letter D. The only problem on this screen that requires the distributive property first would be D. So right here, let's go ahead for right now and let's just underline. We're distributing the 3 in that problem. The rest of the problems on this screen, we're going to skip that step because there is no distributive property. All right, step 2, don't call. What's the C stand for? Look at your notes if you have to. Combine like terms. So do you see any of the other 3 problems where combining like terms might be our first step? Olivia? C. What are our like terms? Very good. There's no distributive property, but there absolutely is combining like terms. So that will be our first step. All right, let's go to the next step. What's the M stand for? What's the me stand for? Hey, in the 2 problems that are left, do we have to move a variable? Okay, remember that step only happens if there's a variable on both sides of the equal sign. So is there a variable on both sides of the equal sign in either A or B? No, there's only one variable in these problems. So we skip step 3. Now we move on to adding or subtracting. So let's look at letter A. What are we going to add or subtract in letter A? We're going to move the 3 and we're going to move it with what? Addition or subtraction? Good. It's a plus 3. So what we do to one side, we have to do to the other. Remember, this is our subtraction property of equality. What we do to one side, we have to do to the other. Now, we bring down what we have not used. So we have not used negative 2n, and it equals, what's 9 minus 3? 6. Good. Now we are at the very last step, which is to multiply or divide. How are we going to solve for n? Divide. Both sides by negative 2. So negative 2 over negative 2 simplifies to 1, which we do not need to bring down. And what does n equal? Negative 3. Awesome. All right, letter B. In letter B, we skipped the first 3 steps. There's no distributive property. There's no combining of like terms. And there's no moving a variable. So Esther, what are we going to do first? Add or subtract? What are we going to add? 11, good. 11 is keeping C from being alone, so we're going to add 11 to both sides. This cancels, and we have 1/2 C. Bring down what we have not used. And then what is negative 21 plus 11? Negative 10. Very good. Now, we're at our last step, which is to multiply or divide. So, Emma, we're trying to move a what? A fraction. And we learned last week, if it's a multiplication problem and the number we have to move is a fraction, what is our shortcut? We multiply both sides by the... You do multiply both sides, but does anybody remember? We multiply both sides by the what? The reciprocal. So what is the reciprocal, Emma? 2. We flip the fraction. So 1/2 becomes 2/1, or just 2. All right? Remember when we multiply a number and it's reciprocal, it again cancels out and equals just 1. So we only have to bring down the equals C. What is 2 times negative 10? Negative 20. And remember, we always want our final answer. We want the variable first. So we're just going to flip it and write C equals negative 20. All right, great job. Any questions so far? All right, let's look at letter C. Now, we already decided there's no distributive property, but we do have to combine like terms. So when we combine negative 2x and negative 10x, what do we get? Abby. All right, good. We would get negative 12x. The signs are the same, so we are going to add and keep, and we get negative 12x. Then we bring down what we have not used. So our next step says to move the variable. Is there a variable to move? Class, yes or no?
Yes.
What's the variable we have to move? No. Remember, there's not a variable on both sides of the equal sign, so we skip that step. All right? We're supposed to then add or subtract. So, Haley, what are we adding or subtracting? We're going to move the 12. We're going to subtract it. Okay, it cancels, and we bring down what we have not used. What is 18 minus 12? 6. Good. And then how do we finish this problem? Okay, multiply or divide. We got to divide both sides by negative 12. So what does x end up equaling? Negative 1/2. All right, very good. Now let's talk about this. First things first, no fraction should ever be given as a final answer if it's not been reduced. All right, we reduce our fractions always. Secondly, it's a negative fraction. The negative sign can go by the numerator or by the denominator or out in front of the fraction. All right, it doesn't matter if you left it down by the negative 2 because it was the 12 was negative, that would be fine. All right. Thirdly, I never want a decimal answer unless the problem starts with a decimal. So don't give me negative 0.5 as an answer. Okay, your calculator will convert from a decimal to a fraction. If you don't know how, see me after class and I'll tell you. But I don't want decimal answers unless the problem starts with a decimal. All right? Now, let's look at letter D. We already decided a long time ago that the first thing we got to do on D is the distributive property. So, Olivia, when I distribute the 3, what do I get? Good. I got to take the 3, multiply it by the x, then take the 3 and multiply it by the 1. So 3x plus 3, and then I bring down what I have not used. All right, Alyssa, don't call. What's the C stand for?
Combine like terms.
Do we have like terms we can combine? What is it? 3 and 6. So we're going to bring down what we have not used, which is 3x. What is 3 plus 6? 9 equals negative 9. All right, Claire, don't call me. What's the M stand for? Not yet. What's the first M stand for? Do we have a variable to move? No. All right. So now we move on to after. What's the A stand for? What are we adding or subtracting? 9. How do we move it? Good. Good. We're going to subtract 9 from both sides. We bring down the 3x equals. And what is negative 9 minus 9? Negative 18. Luca, last step, don't call me after midnight. What's the M stand for? So we're going to do what? Divide both sides by 3. So what does x equal? Luca, what's negative 18 divided by 3? Negative 6. Very good. All right, any questions so far? Great. All right, let's look at letter E. All right, I want you to take a minute. I want you to work letter E with your partner. All right, if we're talking through the don't call me after midnight, what's the first thing that we have to do? Isaiah, what's the first thing we have to do in letter E? Okay, distributive, what are we distributing?
The 2d minus 3, 4 times.
The 4 is being distributed by the 2d minus 3. Awesome. So we bring down what we haven't used, which is 15 equals 5. And then what did you get when you distributed the 4?
8d minus 12.
Okay, a positive 8d. Then 4 times negative 3 is a negative 12. All right, what was the next thing you did?
I combined my terms.
Which were?
Negative 12 and 5.
Okay. So 15 equals, what did you get when you combined 5 and negative 12?
Negative 7.
Okay, bring down the 8d. What did you do next?
Added 7 to both sides.
Good. So 15 plus 7, 22 equals, bring down the 8d. Keep going.
And divided 8d to both sides.
Okay, and what did you get? Do I want a decimal though? No, the problem didn't start with a decimal, so don't give me a decimal answer. Who can give me the fraction answer that I'm looking for? Abby? Leave it improper. Yeah, leave it improper. I don't need mixed numbers. All right, you can leave it improper, so it actually is 11 fourths. And again, don't forget, final answer, D equals 11 over 4. Okay? 11 over 4. Reduced fraction, leave it as an improper fraction. All right, let's look at letter F. Who can tell me what I'm going to do first on letter F? Gage.
Combine 9x and negative 6.
All right, no distributive property, but we're going to combine our like terms. So negative 12 equals 3x plus 15. Then what, Gage?
Subtract 15 from the other side.
Okay, subtract 15 from both sides. So we have negative 27 equals 3x. And then finish this off, Gage.
Divide by 3. X equals negative 9.
X equals negative 9. Again, make sure that the x is first. Good job. All right, let's look at letter G. Letter G. What are we going to do first, Esther, on letter G? All right, again, we got to distribute the 5 and we got to distribute the 2. So what do you get when you distribute the 5, Esther?
You get 15 minus 5x.
Okay, 5 times 3 is 15. 5 times negative x is negative 5x. And when we distribute the 2?
You get 6 minus 2x.
Good. 2 times 3 is 6. 2 times negative x is negative 2x. And it equals 14. All right, Esther, what would you do next? We're going to combine like terms. So what are your like terms?
5x and 2x.
Be careful. What kind of 5x and what kind of 2x?
Negative.
That's a negative 5x and a negative 2x. Any other like terms?
15 and 6.
Good. We also got 15 and 6. So combine those and what do you get?
You get 15 and 6, 21.
Okay. Signs are the same, so we add and keep, so we get negative 7x. It equals 14. All right, what would we do next? Isaiah?
Then subtract 21 on both sides.
Good, we're going to subtract 21 for both sides. So negative 7x equals
Negative 7.
negative 7. And finish it off.
Divide negative 7 to both sides.
Good. Divide both sides by -7. So x equals 1. Hopefully you guys have room. You can do that right underneath. But x equals 1. All right, letter H. Can anyone look at that and tell very quickly what step you're going to drop to? What? Add and subtract. There's no distributive property. There's no combining like terms. And there's no moving a variable. So we're going to gauge.
Add 3 to 5.
We're going to add 3 to both sides. That equals 0. So 8 equals, bring down what you have not used, z divided by -4. All right, Alyssa, how am I going to solve for z? Not by the reciprocal, not this time. We're not moving a fraction. So what are we going to multiply both sides by? What's keeping the z from being alone? So we got to move it. So we just have to multiply it. It's a division problem, so the inverse of division is multiplication. So we're just dividing both sides by -4. So z equals, class? Good, and remember we want the z first. So z equals -32. Any questions so far? All right, now we've got another shortcut. Remember, we're always checking for the distributive property first. Well, what if the number that we're supposed to distribute is a fraction? How do we move fractions from one side to the other when it's a multiplication problem? Again, you've got a fraction and a parenthesis with nothing in between. I mean, this is the distributive property, okay? Make sure if you didn't correct this on Friday, that is supposed to be x plus 3. But instead of distributing a fraction, why would we keep a fraction around any longer than we have to? All right, it's a multiplication problem, but we can actually move that fraction first. How do we move a fraction to the other side? What's the shortcut? Look at the sentence that you're supposed to have put in your notes. When the number needing to be distributed is a fraction, multiply both sides by the reciprocal first. So it's our same shortcut from last week. If we're going to move a fraction, we are going to multiply both sides by the reciprocal. So we multiply by, what is the reciprocal of -6/5? -5/6. So again, we're going to multiply both sides because on the right side it just simplifies to 1 and we no longer need it. So we're left with x plus 3 on the right. And what is -5/6 times 66? You can do it on your calculator or you can do it in your brain. If I do it in my brain, 6 is in the denominator and goes into itself once. 66 is in the numerator and 6 goes into it 11 times. So what is -5 times 11? Class? Good, -55. So I've only got one step left, and what is that step? Okay, but which one am I going to do? Subtract 3 from both sides. So x equals, what's 55? -55 minus 3? -58. And again, we're going to make sure the x is first. Okay? Awesome. Now, look at letter J. What needs to be distributed? Haley, what needs to be distributed in letter J? Does everybody see the distributive property? You see that that's what needs to be done, right? Anybody confused? All right. So Haley, what is outside the parentheses? What is supposed to be distributed in this problem? 3/10. Okay. So if the number needing to be distributed is a fraction, what's our shortcut? What can we do with it? Good. What's the reciprocal of 3/10? 10/3. So we're going to multiply both sides by 10/3. Knowing that on the right side it simplifies to 1 and we can just bring down the x plus 2. And then what is 10/3 times 12? 40. Again, 3 goes into itself once. It's a denominator. 12's in the numerator. And 3 goes into 12 4 times. 10 times 4 is 40. How do we solve for x? Subtract 2. So what does x equal? 38. Awesome. So x equals 38. Okay. Any questions? Again, this is just a shortcut. Can you distribute the fractions? Absolutely. But you're going to be dealing with fractions for a lot longer than you actually have to. All right? Now, real world situations. Ms. Johnson, when are we going to use multi-step equations in the real world. Well, here you go. In example number 2, we're supposed to write and solve an equation. So letter A says you spent $50 on supplies for the bake sale. Each item sold for $2. After the sale, you had a profit of $180. How many items did you sell? Now let's go back here. We spent $50. Are we adding $50 to our profit? Or are we taking $50 away? If we spent $50, we're taking it away. Awesome. Now, anytime you see each item or per item, what operation should come to mind? Addition, subtraction, multiplication, or division? Multiplication. If I have 30 items on my table and they're each $2, how much money am I going to make if I sell them all? Well, how'd you do that? You multiplied. So 2 times each item. Well, we don't know how many items, so the item becomes our unknown, but we know we're multiplying it by 2. Okay? So that is what we are now going to subtract 50 from. 2 times X is going to give us our profit, but we got to take off $50 because we spent money. All right? After the sale, though, we have a profit of 180. So how are we going to finish this equation? Equals 180. And then we're going to solve. Okay? No distributive property, no combining like terms, no moving the variable. We're simply going to add 50 to both sides. 2x equals 230. How are we going to finish this problem? Divide by 2. So x equals 115 what? Be careful. What did we find? Items. So make sure you label it. It's a word problem. We always label our word problems. But we sold, if we profited $180, we sold 115 items. Any questions? All right, take a minute and work letter B. Emma, if it says 8 plus, what am I writing down from the very beginning? 8 and what? It says 8 plus. So I'm going to write down, literally write down 8 plus. Good. Now it says the quotient of. The quotient of is the answer to what kind of a problem? Division. So I'm going to put my fraction bar because remember, we're using fraction bars this year for division. Now it's the quotient of what 2 things? Whatever comes first will be my numerator. Whatever comes second will be my denominator. This says a number. What do we replace the words a number with? A variable. So let's just do x. Now it's the quotient of a number or x and 3. So what's my denominator? What's my denominator? 3. All right. Is. Last week we discussed this. Is can be replaced with what math symbol? Equals, and it equals -2. Again, no distributive property, no combining like terms, no moving a variable. So we are simply going to subtract 8 from both sides. Bring down x divided by 3. It equals -10. And how do we finish this? Multiply both sides by 3. So x equals -30. Awesome. And that is lesson 1.2.